Whoops. Okay, implement a class called rectangle that works just like the other graphics classes, such as circle or line. A rectangle is constructed for 2 corner points. The sides of the rectangle are parallel to the coordinate axes. You do not yet know how to define the output operator to plot a rectangle. Instead, define a member function called plot. Supply a function move, pay attention to const. Then write a sample program that constructs and plots a few rectangles. Okay, let's try that. Let's do that one. Let's start up Visual Studio. That's the easy way to do it quickly, so we don't have a lot of time. Let's see. There's there we go. You know what? I'll do it down here. Where's that? Here. All right, let's start a new project. And this is a graphics program, P514. Just going to leave that out. Delete that. And I think what I'm going to do is just, it's graphics, so we're going to need this stuff here. I'm just going to copy that. And now I'll just add those files in. And I forgot to turn off the Unicode. Let's do that. Oh, it's turned off. Oh, there it is. Sorry. And let's see if it builds. I'm going to make it the startup project just to get it there. So, it does not build. What's the issue there? This is 514. I think I didn't do something right there. Let's try that again. This is use the Unicode character set. Sorry, I made the mistake there. What's that? Oh, I didn't apply. Oh, thank you. There it is. Thank you. Apply. Let's see if it runs. Okay, so that's our old code. We're going to replace that. And we're going to replace it with some test code that draws a rectangle. Let's go ahead and do that. And so we're going to do something like this. We're going to create a rectangle. And a rectangle will be say comprised of an upper left point and say a lower right point. Well, let's do it something like that. And that will print that. And the book said that we don't know how to use the output operator. We don't know how to define the output operator. So we can't do that. That's how we would normally do it, right? So we can't do that. So instead, what we're going to do is implement Is it plot or was it draw? What did he ask for? I think plot, right? Is it plot? Huh? Yeah, plot. And also he wanted move as well, right? Okay. So this call to plot will do what we've been doing with this output operator. And then let's try to do this. And this is move. Let's move it in the direction 1, 1. And then we'll plot it again. Let's see if we can move it and plot it. There's our test code. So we write the test code first. This is called, what do we call it? Test first strategy, software development. And now rectangle left, this needs to be, this is a point. So these are points. So upper left, we'll make that equal to, say, minus 3, comma 4. And the lower right, we'll make that positive 3, minus 4. Positive y, does it go up or down? Huh? It goes up? Alright, so normally you don't, when you work in screen space, positive y goes down. So here the author has it positive y going up. So this is the upper left. So that's okay, that's good for upper left, right? And this is good for lower right. And but rectangle is not defined. So we need to define it. And what we're going to do is define it in its own class, in its own file. So we're going to include a file called rectangle. We're going to put it in what's called a header file. Let's create that. So let's add a new item, a header file, rectangle. And here we'll define a class called rectangle. Did it again. Don't need that space there. And we have a public section, and we have a private section. That's how those look. In the public section, we'll have a constructor, and the constructor takes 2 points. Let's do it like this. And then what we'll do is we'll store those points as private member variables. Now notice we're getting a syntax error on point. That's because point is in this compilation unit, this file. The compiler does not have a definition for point. So you have to tell it where to get that definition, and basically it's here. You have to put this header file in there. There it is. Now we don't get a compilation error on that. And if we come back to here, we see that now the constructor looks good. No red marks on that. But this this doesn't look good. This is the constructor. What's wrong with this? Rectangle is undefined. Rectangle, upper left. It takes 2 points. So what is going on there? That should be okay, right? Rectangle. I'll try to build that. So plot is not defined. What does this include here? Cannot open source file rectangle.h. Rectangle.h. I wonder why that doesn't show up there. Why is it? What's that?
Is it because you don't have a C++ file associated with the rectangle.h?
No, we have the that would be a linkage problem. So that would, and I want to illustrate that we're gonna fail to link. But this, by having this declaration of the class here and including it in here, we will we should be able to build this compilation unit on its own. But when we go to try to link it to the missing rectangle implementation, it won't be able to find it, and it'll report a linkage error. But now, so why does this not show up there? Why does that not show up there? It's inside here, isn't it? There's the rectangle right there. And that doesn't make any sense to me yet. This is include rectangle.h. That should be okay. Alright, we need to implement plot and move. Let's hold on that one. Let's do the stuff that we know we need. So here's plot. Plot is void. And I think that's lowercase, right? Plot. And move. And move will have something like this. That's the amount to move in the x direction and the amount to move in the y direction. Sorry, this should be a void. Okay. So here we're declaring, this is like the interface to the class. The class has a constructor that takes 2 points. It has a function called plot that takes no arguments. It has a function called move that takes 2 double precision floating point numbers. And these are some hidden variables. So we're going to keep track of the upper left and lower right corner points here. So this we haven't implemented these 3 functions. So we can't. The program's not going to run, but we should be able to build this class here. So let's try this again. I'm going to see what's going on. So well, there it is. There's the linkage error right there. And why is this cannot open source file rectangle.h? I don't understand that, because I think that it can in fact open that. Why don't we get that error with this message? That doesn't make any sense. We can open this file. Why can't we open that file? That doesn't look right to me. But there's something wrong with Visual Studio. I'll try this again here. We like spelling something wrong. Look at this. Unresolved external symbols. So here we have a linkage error. But notice that that error message that we were seeing before is gone. So that's a bug in Visual Studio. You see that? All I did was I closed Visual Studio and opened it again, and now I don't see that error report. Or do I? No, I don't. It's not there, right? So we're working with imperfect software. All right. Let's go ahead and implement this rectangle class. So, as you can see, we can compile. And let's take a look at that. So here's where we're at, is 514. And you can see in here, see these OBJ files? Those are the compilation units that are been translated into machine instructions, unlinked machine instructions. And there should be a main. There's a main.obj. But notice there's no rectangle.obj. That's what's missing. So the compiler will generate main.obj because we told the compiler through this header file here, we told the compiler that yes, there is a class called rectangle, that yes has a constructor that takes 2 points, and this rectangle class is a plot function and a move function. So go ahead, generate the object code. Generate the unlinked code of machine instructions. It's machine instructions plus some missing pieces in there where functions get called into other functions correctly. So let's go ahead and implement this rectangle.cpp file. Not class. I want what is this? I'm going to add a new item. We need to include the header file. And now we're going to provide an implementation of these 3 functions. So I'm just going to copy those. And what you see here with the code that we're developing, this is essentially what you do in any programming language that has objects. The syntax can be slightly different, but it's essentially the same procedure that you go through. Oops, so this is a constructor, and the implementation of these functions, we need to assign them to the rectangle class. We do that by prefixing the function names with the class name, followed by 2 colons. So when we're telling the compiler, hey, we're going to implement the constructor for the rectangle class. Remember, the constructor is just a function that has the same name as the class itself. And here's the plot function. We need to implement the plot function, but that, once again, we have to tell the compiler it's not just any old plot function. It's the plot function that's a member function of the rectangle class. So this is the syntax that's needed to make that association. Start tighten that up a little. So here, oh, you know what? I think the book covered this. The initialization list. Is that right? Does the book cover this? You know what? I'm not going to do it like that. That's too confusing. So this is point, I'm going to call this my lower right point, my upper left point. So the upper left that's in the class is set to the upper left point that's being passed in. We do the same thing with the lower right point. So inside these functions, so we're implementing this function. keep in mind that when you implement this code inside here, can access the variables and other functions that are in the class. In this case, we're not, as we implement the rectangle constructor, we don't need to access these other functions, but we do need to access these variables. These are called private. That means functions on the outside of the class cannot access these variables directly. The only code that can access the state of these variables directly are the functions that are part of the class itself. So the constructor, the plot function, and the move function. That's what we're doing. So upper left is a variable in our class, lower right is a variable in our class. We're going to set those to the 2 points that are being passed in. And then we have plot. For plot, let's do this. Let's just print these two values here, upper left and lower right. This is, so we're not going to go all the way yet. This is the lower right. Let's just do half the job first. Just print the corner points. And move, let's not do anything. Let's just leave move alone. So that's called a stub. These are both stubs. That's also a stub. It's an implementation of the function. It doesn't solve the problem. It just gets us part way there. Let's go ahead and build this. There it is. It looks good. Let's run it. There's our 2 points. That's the upper left. That's the lower right. Now what we need to do is draw the lines here, right? So there's 4 lines to draw. We need to draw 4 lines. Right? So when we call plot, what's happening is this code is running and we're just printing the corner points. So we need to put code in there that prints the lines, not just the points. So let's go ahead and do that. We're going to need the other corners. So we have upper left. Let's get the upper right as well. And let's also get the lower left. Now the upper right, see, the only things we have to work with here are upper left and lower right. So the upper right is going to be the y value for the upper left and the x value for the lower right. And this, once again, we're going to do this a step at a time. We're not going to go for everything all at once. We're going to do it. We're going to solve the problem incrementally. Let's just output one line. See if we got the. Well, this is the upper right point, right? Okay. Let's see if we get that. There it is. That's the upper right point. Now let's do the same with the lower left. And the lower left is going to be, I'm just going to guess here, it's going to be the upper left's x value. I'm going to guess this, and then I'm going to check my logic. I'm just using my intuition, and then now I've got to use my non-intuitive brain to check that. So the upper left, that's the x value. That's the same as the x value for the lower left. That's correct. And the lower right, its y value is the same as the y value for the lower left. I think that's right. Let's check it. So that's lower left. Let's see if we got all the points. We did it. We got them. Let's go ahead and let's draw everything now. So we have four lines to do. And we just go through these combinations. We have the lower right goes to, say, we can go in either direction, right? Let's do it like this. Let's go, want to go in a counterclockwise or a clockwise direction? Clockwise, right? So we'll say we'll have the, it doesn't really matter. It doesn't even matter. Lower right, and this is the lower left. Let's just get it done. And this is lower right and upper right. And then this is going to be upper right and upper left. And this is going to be upper right, and this is going to be what is this one? Something right. Is it lower right? Just going to do it fast here, running out of time. We didn't get it. Which one is wrong? Should be what? Upper left, and lower left. Thank you. Good, thanks. I don't know how you did that, but that's the answer. But that works, so we're gonna. And we don't need all this stuff anymore, right? We don't need to output this. Just output that. Now we're writing this twice because move does nothing. So to move, we just move the two points. So we're going to call move on the 2 points. That's dx comma dy. Sorry about that. This is the lower right. There it is. You see, you get that? We don't have to move all the lines, right? Because plot, if you look at plot, the idea about plot, and you said it's completely dependent on, it's only dependent on those internal variables, upper left and lower right. So when you want to move the whole rectangle, you just have to move those 2 corner points. Because plot is written in terms of those 2 corner points. Now one other thing here. Move cannot be declared const, because it modifies the state of the class, the state of the object that was created from the class. But plot does not modify the state of the object. So what we need to do, well, we don't need to do this, but the book mentioned that we need to pay attention to const, if you notice that. And it's good practice, although it's not required, it's good practice to declare functions as constant that do not modify the state of the objects for which they're members of. Let's see how that works. There it is. So that's it for 514. And that's it for today as well. So we'll see you in lab.